So now we are going to understand how to fit a straight line. Fitting a straight line. Suppose we have n set of observations in an experiment x1, y1, x2, y2, etc. xn, yn. And we wish to fit these observations with a straight line y is equal to ax plus b. We have to determine the coefficients a and b using the principle of least squares. For any xi, when I is equal to 1 to n, the observed value should be equal to yi, and the corresponding expected values will be axi plus b, since the assumed equation is equation of a straight line. So when you put the value of I equal to 1, it will be expected value of y will be ax1 plus b, and so on. Now we have observation set and the expectation set. Naturally, we can find the corresponding residuals for each observation. So in general, ei is equal to yi minus axi plus b when I is from 1 to n. Then what about the sum of squares? Capital A is equal to square of this small ei, yi minus axi plus b. Here we have to put the summation sign from I is equal to 1 to n. And last slide we discussed the condition for a best fit by the principle of least squares is the capital E should be equal to 0, or it should be minimum. Here we can see that E is a function of A and B. Let's see further. Once again, we remember the equation for capital E is equal to yi minus axi plus b the whole square. Since E is a function of A and B, and if we want to find what is the necessary condition for E to be minimum, we have to do partial differential of E with respect to A and that with respect to B, and it should be equal to C, 0. That is dou E by dou A equal to dou E by dou B equal to 0. First of all, let's do dou E by dou A. This is just like a function with square. Do the partial differential. For easiness, we can put I is equal to 1, 2, etc. up to n, and you will get this equation. Do yourself and make sure you are getting this equation. Okay, dou E by dou A is equal to 2x1 y1 minus ax1 minus b plus etc. up to nth term will be 2xn yn minus axn minus b equal to 0. On the next step, we are going to generalize this dou E by dou A. You can see the terms of xn yn, xn square and xn b. This we are opening the bracket. Instead of n, we are giving the subscript I and generalizing. What we are going to do is, we are keeping the xn yn term to the right hand side, all the other xn square and xn on the left hand side. So rearranging, because this is equal to 0, you can move this terms to left and right as we wish. And finally, after all the rearrangements, the rearrangement part is very simple. You have to do yourself and you will get A into sigma is equal to 1 to n xi square plus B into sigma is equal to 1 to n xi is equal to xi yi. And this is equation number A. And remember, this equation is very, very important regarding this least square method. Hoping that you got the equation. Solve it, rearrange, and you are reaching to get the equation A. Let's move further. Do the second part, dou E by dou B, and that can also be generalized as A into xi plus nb is equal to sigma is equal to 1 to n yi. That is the equation B. Do yourself, make sure you are getting the equations on the last slide A and the next slide B. And these equations A and B are called normal equations. Very important. We need these normal equations in problems to find the best fit and to find the curve fitting using least square method. Now we can compute E. What is capital E? It is the difference between observation and the expectation and the observation. So yi minus axi minus b. So doing that, and it should be sum of square of residuals. Go back to the, you can see that what is small ei and small ei the squares. Here we are seeing small ei squares, and again expanding. This is just rearranging the above equation, and finally you will get capital E as yi square minus a into xi yi minus b into yi. This equation is also important, capital E. So altogether what he had seen to fit a straight line. Let me go back to the earlier equations, earlier slides. We have n set of observations. So when x is equal to x1, the observation will be x1. When x is equal to x1, the expectation will be ax1 plus b. That should be your idea. And the difference is the residual, and sum of squares of this residual will be capital E, and we are finding the condition for the minimum value of E. Then let's do an example. This is a problem using the method of least squares. Find the straight line y is equal to ax plus b that fits the following data. You can see a set of observations of any experiment, and we have to fit this data with a straight line. Y is equal to ax plus b. For this we need the normal equations that we discussed earlier as equations A and B, and I had given in this slide also. The given straight line is y is equal to ax plus b. You are here provided with a set of observations, and we are writing the corresponding normal equations by the method of least squares. Writing the equation A and writing the equation B. Looking on to the equations A and B, you are familiar, you will get an idea that in order to find cap A and B, what you need? Xi square is required, xi is required, xi yi is required. And we just tabulate the needed things. The given x, given y, taking the product, since we need xi yi, we are taking the product, and we need what else? X square. So corresponding, if x is 0.5, y is equal to 15, and xy will be x into y, 0.5 into 15, that is 7.5, and x square, if x is equal to 0.5, x square will be 0.25, and calculate everything accordingly. And take the sum, because we need sum. Sigma xi is 10.5, sigma yi is 82, sigma xi yi is 127, sigma x square is 22.75. This you are taking the sum of all the column values. Got the point? Then it is very easy that you have to substitute these values in your normal equations. So substituting back, sigma xi square is 22.75 and sigma xi is 10.5. Equation A will become 22.75a plus 10.5b is equal to 127. Similarly, equation B will become equation D on substituting the required values of sigma xi, sigma yi. In the equation B, you can see small n. It will give you, small n is the number of data points. Number will be 1, 2, 3, 4, 5, 6. So n is equal to 6. So you have to put 6. This is the number of data points, number of x or number of y. So the equation B is rearranged as 10.5 plus 6b is equal to 82. Now it has got the simplest form of two polynomial equations having the coefficients a and b. Rearrange, solve, you will get a as minus 3.7714 and b as 20.2667. And the required straight line fit equation for the given data will be y is equal to minus 3.7714 x plus 20.2667, and this is all about the problem of fitting a straight line. And you can see a and the required fit for the given data is minus 3.7714x plus 20.2667. Thank you all for being attentive, and I hope you got an introductory idea about curve fitting, basics of least square method, and about residual, sum of residual squares, and then how to fit it with a straight line. Listen carefully the video again and again. You will get the complete idea. For more details, you can see the textbook by Shankara Rao, Numerical Methods for Physicists and Engineers. That portion can be scanned to you all, and an assignment will be there on the Moodle platform. Do it yourself. While doing the assignment, you have to keep it in mind that you studied fitting a straight line. If the assignment has any equation that is not in the form of a straight line, try to change it into the form of a straight line. Then solving the equation will become more easier. And let's discuss the queries in live chat or anything else, any platform else. Hope that you all are safe. Thank you all.